Okay guys, today's lab, what we're going to be doing is comparing some intermolecular forces of different organic compounds. So if you read through your lab handout, you'll realize the ones that I'm going to be doing. We've got hexane, this is the yellow one today. We've got the white one, which is methanol. We've got the pink one, I know it's a green label, but I use pink on the probe. That one is pentane. We've got the red one, which is butanol. And then we've got the orange one, which is propanol. And the last one, this blue one, this light blue one, is methanol. So now what I have done today to try to keep everything organized is I've used the color that is on the label, and I have labeled the probes with that same color. And just like in sophomore year, we have created a wick that's going to sit at the very tip of our probe. All the wicks that I cut them up earlier. They are all 1 centimeter or 1 inch by 2 inch wicks. Okay, and I know you can't read those numbers very clearly, but I'm going to show you how I put a wick on one of these, and then we'll roll with the experiment. So to put the wick on, all I did was I just kind of rolled it onto the end. Okay. And then once I rolled it onto the end, I just took a rubber band and I just kept on twisting the rubber band until I got enough twists in it that it was going to hold that wick into place at the end. Now what I tried to do with all of them was get the exact same amount of space. In fact, I'll do it right here as well just to show you. Try to get the exact same amount of space on the wick for every single trial. Okay, so now all I'm going to do is I'm going to open up each one of these containers and I'm going to put the wick inside and let it soak. And then I'm going to look at my lab handout and I'm going to say, oh look, trial 1 is this, let's roll. Trial 2 is this, let's roll. So I'm just going to open up all of these and let the wicks soak up material. Okay, and then we're just going to look at what the starting temperatures are of these, and then I'm just going to hit go, and then I'm going to pull them out of their material or out of here, and then I'm going to anchor them onto the side of the table over there. You'll see them anchored this way towards you, but I will be following on here on the CAS as data is collecting. So the very first trial of ones that we need to do today, the very first trial is ethanol versus methanol. So I've got ethanol, this is blue. I am plugging it into channel 1. And then I'm going to grab methanol. Methanol today is the white one, so I will pull this one over to here. And I will plug methanol into channel 3. Okay. And now, today, we are going to look at time-based. We're going to look at a duration of 300 seconds, and I want to do 3 samples per second. I don't know why this cradle is giving me that issue. I hope that it will not be an issue as we're rolling on. Okay, so now these 2 probes are set. I've got 300 seconds. I'm going to hit play and pull them both out at the same time. Put them next to each other so they're in the same location. Anchor them down so that they're not moving around and sliding around. And then I'm going to cap off the methanol. I still need the methanol and the ethanol later. so I'll leave them uncapped. But I'm going to let this run until the trial is done. Now that does not mean I'm going to let it run the whole 300 seconds. I'm going to let it run until a certain moment in time, and then I will stop it and we'll start the next one, so that you're not just watching like an hour of lab. Okay, we've got 4 different trials to run. So channel 1 is the ethanol, channel 2 is the methanol. The blue one is the ethanol, the red line is the methanol. And I feel we should be listening to music in the background while we're doing this lab, but we're not going to. So what I want you to think about as you're watching these go down is, when do you think they'll stop? Or what do you think is happening that's making the graphs do that? Why are they arcing on a downward angle? And then it looks like they're kind of turning into like this U or this parabola thing. So, but it looks like we're slowing down. Temperature is still decreasing. Still going down. Still going down. We're down to 5.6 on methanol, 11.8 on ethanol. 5.4 methanol, 11.7 ethanol. Ethanol is 11.6, methanol 5.3. This is the most exciting, 5 minutes of television you're ever going to watch. No, we have another couple that'll be even more exciting. So, getting closer. Getting closer. So, what's the difference between ethanol and methanol? What are their structures? How do we write them? You just had your basic brief on organic chemistry, along with a quick look at functional groups. So how is this working? All right. Looks like we're at 10.8 and 4.7. .6 and 10.7. What will happen? Why is this slowing down? What's going to happen after a certain amount of time? What do you think the graph's going to look like? Okay. Trial is almost up. And then we'll just roll right into the next one. The next trial we're going to be doing is going to be Butanol and N-Pentane. So Butanol and N-Pentane is the next trial that we're going to be running. I am going to save between each, and I'm going to save it with the name of the trial we just ran, so that when you're trying to get the data off of the classroom page, you know which one you have to go to get the right data. Okay? I will post it as a CSV. I will also post it as a TI Inspire file as well, so that hopefully one way or another you're going to be able to get it. Okay? And we are done. 300 seconds. Okay. So I am going to go Document, File, Save as, and this one was ethanol, methanol. So I'm going to save this as meth. Okay. And now I will close this off. And we're going to put these two back where they belong. We're going to open up the file again. And this run is going to be butanol and pentane. So here is butanol. Butanol is channel 1, okay? And we will do pentane in channel 3. So butanol is going to be blue. Pentane is going to be channel 3. Okay. All right. Okay, we got good temperatures. We're going to change this to 3. We're going to change this to 300. And then we're going to hit play. Pull them both out. Put them down here and anchor them. All right. And now these ones we can cap because we are not going to use pentane or butanol again. So I'm going to put those off on the side table, get them out of the way. I'm going to anchor this one just a little bit better. Okay, so remember that the blue one is butane or butanol. And the pink one, or the red one, is pentane. Top one is butanol, red one is pentane. Already, what's different about these two graphs? What are you noticing happening here that's different from the first two? And start to write down some notes, start to jot some notes down as to why you think these might be different. Maybe draw their structures. Maybe look at the pre-lab and look at the structures that you already jotted down and look at the information you already jotted down and start coming up with ideas of why you're seeing this difference in the graph. Okay? So the more information, the more that you jot down now while you see it, when you first experience it, the better of a job you're going to have or the better time you're going to have actually writing down some of those reasonings why when you actually get to your actual lab report. Now take a look at the graph again and notice it's starting to do something. This red one, the red line, it went all the way down and now it's starting to increase again. And wow, okay, the red line is pentane. So why did pentane go all the way down and then start coming back up again? What's happening there? And then why is butanol, the blue line, not doing that? Interesting. Okay, we're getting closer to the end of this demo. We're getting, or this lab. We got 2 more trials to do after this. So, but we're pretty much done collecting data on this one. Okay? If the whole point is to be able to rank these, we're pretty much done collecting data on this one. So we can try to save some time that you have to sit watching videos. But I'm curious. I'm curious what that red line is going to do, because it's starting to come back up, but you're also noticing that it's starting to level back off. So why is the red line starting to level back off as well? Interesting. Another observation is take a look at these two wicks, okay? And you can kind of see it from the angle that you're at. And in fact, let me bring the camera a little bit closer and then I'll put it back. But take a look at those two wicks, okay? What's different about this one from that one? That one still looks like it's, dripping, and that one looks like I didn't even put any material on it. This one's a dark brown, that one's a real light brown. It's because it looks dry, because it is dry. So, once again, why then is the one going up and the other one not? Okay. I'm going to call a halt on the data collection on this one. We don't need any more of that. We're going to go to Doc, File, Save As, and this one is channel 1. The first one was butanol, so this is going to be but, and the second one is going to be pent. And then enter. Okay. We're going to go ahead and close this. Disconnect these two. Start it back up. And now I can get rid of these two probes as well, because we are no longer using those two. Third trial is methanol and hexane. So I'm going to pull methanol back. That's going to be my first channel, my channel 1. Okay. And then hexane is going to be my channel 3. So methanol is going to be blue when it reads and registers. And hexane is going to be this red one. Let's try opening it again. All right. We will come back and do the next two. Okay, guys, we have a new cradle. We're ready to roll. I know, didn't even seem like any time passed for you, but a couple of minutes passed for me. So here we go. We are just going to change these settings. Remember that the first one, this blue one, is going to be methanol. The second one, this red one, is going to be the hexane. Okay, so I'm going to change this to rate 3, and then I'm going to go here, change this to 300. Okay, and then I'm going to hit play, and away we go. Okay. Okay. We are anchored. And hexane and methanol are now done today. So I'm going to cap those off. Remember that the blue line is methanol, and the yellow line is hexane. Well, sorry, the red line is hexane. Got to change its positioning. It keeps on wanting to migrate. Okay. So, wow, these guys are walking pretty hand in hand. So how are you going to be able to determine which one's better based on this data? So now it becomes really important when you're looking at this data set, looking at both of these lines, racing down, seeing that they both started at about the same spot. About the same spot. See where they come down to. And then, how can you tell which one has the weaker IMFs? What can you do when you are looking at a changing slope? At what point would you want to do something with that changing slope? And why do I keep on talking about it as changing slope? But this is something that's happening over time. And what's happening over time? Just interesting things to think about as you're watching these two data points start collecting. Remember that one more time, the blue one, which is the white probe over there, is methanol. The red one, which is the yellow probe over there, is hexane. So this is our methanol hexane run. And something that I'm noticing right now on both of these is that these two are both still pretty saturated. Both of these two probes, where I have them placed, are pretty saturated. So they're not at all clear like that one was I think it was the pentane. The pentane dried completely. So we've got about, another 125 seconds to go here. But now's a good time. You've made your observations on this. You now have a couple sets of data that hopefully you pulled the data down and you're looking at that at the same time that you're watching these videos to figure out, how do you want to analyze this? What are you observing here and how the data is collected that you can analyze? So I'm not only going to give you, or I'm just going to give you the graphs, not the graphs. I'm just going to give you the data. I'm not going to give you the graphs. You might have to recreate these graphs for the lab report. You can do that with just connect the dot graphs on Google Sheets. Or if you have Excel, you can do the same sort of a thing as a connect the dot graph in Excel too. So, all right, we look to have leveled off. And what normally happens when we level off is we're going to start doing something else afterwards. What did the pentane do? But we might not see that before the 300 seconds elapses. Just a little bit more time. But I think that we have the data that we need now to be able to run the last one and finish this lab up. So I'm going to go ahead and stop. I'm going to go to Doc, File, Save As. We're going to save this one as meth space hex. Okay. I'm going to close it. And then let's set up the last trial. Okay. Don't need these anymore. But what I do need is I need ethanol and propanol. So ethanol is listed first in our pairing, so I will put ethanol inside of channel 1. Propanol is listed next, so I will put propanol in channel 3. Okay. And then let's set up our lab probes again. Okay. There they are. So we're going to do 3 samples per second. We're going to do 300 seconds. And then we're going to hit play. So remember, the blue line is ethanol, the red line is propanol. anchor these. All right, and this is the last trial, so I can finish capping up my chemicals. And we can watch this graph develop. So first thing that you're observing right now, take a look at these two lines. The blue one seems to be going faster downward than the red one seems to be going faster downward. Well, no, it's not going fast down at all. Well, compared to some of the other ones that we did, it might be moving a little faster, but still have to think about how do you want to actually figure out which one, because I'm asking you to rank the IMFs in all 6 of these compounds, all 6 of these molecules, all 6 of these organics. We have 3 of them, no, 4 of them that have an alcohol group attached, and we have 2 of them that do not. So at what point does the alcohol group make a difference? At what point in our comparison? Because what do we know about alcohol groups? What type of additional intermolecular force is present when we're dealing with an alcohol group? Okay, now look at the ones that are not having an alcohol group. I gave you 2 big ones. I gave you pentane and hexane. And pentane we saw, wow, shoots way down. Hexane, not as quick, but it's still shooting down. What type of force exists there? And there's only 2 that we've talked about so far. So trying to figure out which one is actually influencing this lab, hopefully you're seeing and you're making some connections between the notes and what we talked about in class versus this live lab, well, recorded lab. So, okay. We are rocketing downwards. We are getting closer to saying we are done collecting data for this lab. But we still have a little bit of time to go. So we're at about 150 seconds. We need to get closer to 300. I'm willing to stop it at 240 for you guys. But how would you compare these 2 lines to the other 6 that we generated? Okay, yeah, smarty. I know that one of these lines is exactly the same or should be the same because we did methanol and ethanol first, and you know that first channel, the blue one, is ethanol again. But how does the red channel, you know, that propanol, compare to the blue one? Are you seeing a pattern? Are you predicting what's going to happen next? Is it doing the same thing that the other ones were doing, which is going really fast and then slowing down? So, all right. I think we're almost there. We'll give it another 30 seconds. We'll cut the video, and then I'll post it. This is your lab. Okay? So. Okay. We got 10.6 and 15.6. They look pretty steady, look pretty even right now. Don't seem to be decreasing much more. We got a good shape to the graph. I think you guys can do your analysis on this now. So I will go ahead and stop and then save this one as eth space prop. Okay. All right, guys. So the conclusion questions of this one, the stuff that you got to make sure is inside of your CEJ, is inside of the lab handout itself that you got to help prepare you for today. Other than that, yes, there are some other stuff that needs to go in there inside of that lab, so ask some questions. But think about what are the 2 main forces that we've talked about so far, and how did we observe those 2 main forces in action inside of this lab. So, see you guys in class.